All right, now we're going to look at relearning geometric proofs. So uh, these aren't exactly geometric proofs as much as just kind of looking at what we see and what we can find. So what I see right away is angle 6 and 7. Angle 6 is congruent to angle 7. That's something I can see. That's the only thing we're given. We could also see that 5 and 6 are vertical angles. I could see that 7 and 8 are vertical angles. And that's just what I can see by looking at this thing. So now, if I want to look at some math, let's think about this. Well, I know 5 is congruent to 8. Or no, I don't know that. I know 6 is congruent to 7. And I know 7 and 8 are congruent. And I know 6 and 5 are congruent. So they all have to be the same thing. And all these other angles have to be 1 minus it. So for math, I can say 5, 6, 7, and 8 all have the same measurements. I can also see the other angles are supplementary to these. Those are things that we can find out from just by doing math. Another thing I can find out, since 6 and 7 are congruent, I can also know that these lines must be parallel. I know that because of the alternate interior angle conjecture, or you could say corresponding angle conjecture, or the converse of those. All those would tell us that those lines are parallel. Now, it tells us to prove angle 5 is congruent to 8. So how do we know that? Well, uh, 7 and 6 are congruent. 6 is the same as 5, and 7 is the same as 8. By substitution or transitive property, 5 and 8 are congruent. There we go. Now this one says AB and CD are congruent. So if I see that, that's what I see. AB is the same as CD. So that means that this is the same as that. Now, what else do I see? I see this a big segment. I see segment AB, BC, CD, and segment AD. Now, we eventually want to prove AC, this whole thing, is as big as BD. Well, do we know that's true? Well, it makes sense because BC plus CD is BD. So uh, maybe this is even in the explain, but BC plus CD is equal to that big thing BD. That makes sense because that's the segment angle or segment addition postulate. And then AB plus BC is equal to that whole thing AC. But we know BC's in both of them. And we know AB and uh, and CD are the same. And we know BC is the same. So then, since the left sides are both equivalent, for instance, BC plus CD is equal to AB plus, oh, is equal to AB plus BC, then the right sides have to be equivalent. BD is equal to AC. Just an explanation on why this has to be true. Let's try, and this is both math and explanation all in one. All right, here we know angle 1 and angle 3 are congruent, and they kind of put that in the drawing. I like it when there's a little tick mark there, but not everybody does that. Why is EBA congruent to DBC? This is very similar to the last one, but it's using angles. So what I see is there's angles 1, 2, and 3. I know that angle 1 is equal to angle 3. And so the math to have these ones, I know that angle 2 plus 3 is equal to EBA. 1 plus 2 is equal to DBC. Those are things we know. We know 1 and 3 are the same. So if 1 and 3 are the same, again, the left sides are equivalent. So EBA and DBC have to be equal. I think that's a good explanation. Or you can use transitive property, or you can use substitution. All of those make sense. All right. I think that's probably good for now. And